share a little bit about the journey of the DoD and what it took to move to the pace of relevance with DevSecOps. So we'll get started. First, something pretty interesting, and I think most people don't realize, but we open sourced and shared a lot of the code and the work we're doing in DevSecOps. So please check it out and even come and use it, consume it, even contribute back to that code base if you like. You'll find a lot of great information on the software.af.mil inside the DSOP documents page, but also training videos, created content, and our source code repo is called repo1. So repo1.dso.mil will get you access to the source code of everything we do in DevSecOps. So again, check it out. I think you're gonna be able to see exactly how the stack is architected and the benefit from that. Since I believe it's one of the most advanced DevSecOps stack in the world, but I might be biased a little bit. So let's go over what the DoD Enterprise DevSecOps initiative is about. It's a joint team across all of the departments and all the DoD services, Air Force, Navy, and Army, and this. We are building enterprise services where we are trying to scale and bring the timeliness and modularity and enabling reuse across the department. And of course, we're the largest organization on the planet with the largest budget, but also one of the most complex missions since we're touching jets, bombers, submarines, ships, and tanks and space systems and so on, with nuclear systems as well. So obviously that's intriguing, I hope, for the audience. We are using Kubernetes, part of the Cloud Native Computing Foundation, which is bringing this abstraction so we don't get locked into a cloud or to a platform. So we can have these reusable Lego blocks as containers. We'll talk about that a little bit today. Providing this DoD-wide DevSecOps managed service with collaboration tools and development tools and cyber tools. And we are centrally assessing and approving and accrediting containers for all of DoD inside what we call the Iron Bank, which is our centralized artifact repo of container. We have 300 plus commercial products and open source products on that repository, and anyone can go and check it out. So do so. Everything we do is based on zero trust. You've seen we call this DevSecOps, not DevOps, because of the baked in security. It's not an afterthought. It's not security comes first. It's baked in. And we use the concept of a sidecar container to inject our zero trust and behavior detection into the stack. We also are providing capabilities for AI, machine learning, and deep learning, and digital engineering as a service. So teams can have modelization and modeling and simulation capabilities on top of DevSecOps to be able to emulate systems and weapons before we even bend metal. We have a few people to train this year, 100,000 people. So we are bringing self-learning capabilities in partnership with the Linux Foundation, the Cloud Native Computing Foundation, and O'Reilly the books. So we can have unbiased content to cover pretty much any IT-related topics and bring state-of-the-art DevSecOps curriculums. So why does DevSecOps even matter? Well, of course, the timeliness aspect of this and being able to move to compete for any organization, whatever it is you do, you have that need of fail fast, learn fast, but don't fail twice for the same reason, and continuously deliver capabilities to the actual end user so they can use it and give you feedback and reduce and shorten the feedback loop to be able to really learn fast. And of course, we can get behind and have to be leading in DoD to compete against China and Russia and North Korea. And really, it's the only way to build software in 2021 to move at a pace of relevance. And just in 1 year deploying DevSecOps, we saved 100 years of time that was going to happen, that is not going to happen anymore. So saving a lot of time to the taxpayer and the warfighter. We also save quite a bit of money, about $12.5 million per software-intensive program in DoD. So we have a lot of those. So that's a lot of money saved over the year. And we are enabling reuse of code and modularity and flexibility across teams and across silos and across the DoD, including sharing across Navy, Army, and Air Force, and so on. So the next step of that is, looking at some of the numbers, right? With 106 times faster lead time from dev to prod, 208 times more frequent code deployments, 7 times less failure, 22% less time planned on rework, 50% less time remediating cyber issues, and a mind-boggling 2,600 time faster recovery, with 40% of the development costs reduced on average, and employees that are 2.2 times more likely to recommend the organization, and so enabling the organization to retain its talent. So if you look at a DevSecOps stack and you look at the phases of DevSecOps, you have all these tools, and that's just an example. We have 300 plus tools, so we have many more options, kind of Lego blocks that can be swapped across stacks. If you were to run these on VMs and not containerizing them on Kubernetes, you would have a very tough time keeping up with your dev, test, staging, production environment. And for us, that's per program, per classification level. So you end up having thousands of these environments drifting away and starting to become stale, having to do a tremendous amount of work to patch and update these components if they were not running on containers. Thanks to Kubernetes and containers, we can self-update and move at the pace of relevance, and ensuring there is no drift using the concept of infrastructure as code and GitOps, so the stack can be instantiated and deployed with a push button deployment. Now, to understand the layers, we kind of cut the DevSecOps into layers. We have this continuous monitoring as a sidecar container monitoring the entire stack, continuously monitoring the behavior of the stack. But then we have cut the layers into 5 layers, with an infrastructure layer that could be a cloud, that could be a classified cloud for us, that could be a weapon system, edge system, that could be an embedded system, on-premise data center, whatever. On top of that, you're going to put Kubernetes. We have multiple options. We partnered with multiple companies to bring a CNCF compliant Kubernetes cluster. We're going to put our continuous integration, continuous delivery, CI/CD DevSecOps pipeline on top, which is fully containerized, as we talked about. We're going to bring a service mesh, which brings the management of the traffic between containers, east-west traffic management across these containers. For A to talk to B, it has to be whitelisted, and we'll talk about the value of a service mesh later. And then the application team is left only with about 10% of the NIST cybersecurity controls left to worry about, inheriting a lot of security and baked-in security and abstraction and capabilities day one. So that fast track the ability of teams to build these Lego blocks faster. Now, why did we pick Kubernetes? We talked about the vendor locking aspect. Containers are immutable, so we can centrally accredit them, and we can use them across environments, from on-premise to different clouds to edge use cases. And then, of course, Kubernetes brings a lot of added value with resiliency, with self-healing, so containers that crash can automatically be restarted. The concept of a sidecar container, which is a small container that runs alongside each container automatically. So Kubernetes will inject that sidecar container very much like a sidecar of a motorcycle, where that sidecar container is alongside, not inside, and is going to inject cyber capability and visibility and prevention capabilities and detection capabilities as a sidecar container. So it's decoupled from the container, it's injected, can be updated without having to update the container, and effectively ensures that we have this zero trust stack across the entire cluster. So by using the concept of a sidecar container, we are guaranteed that no matter if the development team forgot about cyber, we have that cyber capability injected across the entire stack. Now, the concept of Lego blocks that can be swapped with no downtime, thanks to the load balancing and modern routing of Kubernetes, gives us that adaptability that gives us the flexibility we need to move fast. And the automation is brought to us with infrastructure as code and GitOps to enable the instantiation of the stack with a push button deployment. Auto-scaling gives us the ability to scale up and down based on memory and compute and storage needs. And so that gives us a lot of flexibility when it comes to scale. Now, we created these Cloud One and Platform One team, and you see the logo behind me, pretty cool stuff. When you think of having that central team empowering all these development teams, the contractors, the different agencies working with us, effectively that streamlines and enables teams to focus on their mission, so they don't have to reinvent all those basic layers to be able to code. We have teams across the U.S. doing a lot of cool stuff, from space to F-35 to the IoT of DoD to nuclear systems to cyber offense and defense work. So we're doing a lot of everything pretty much. And that team has been funded about a year ago, and we have now 2,000 microservices, Lego blocks that were created in our environment, with 153 teams in that environment and 2,300 developers on that multi-tenant environment, and 340 now, I think 350 containers approved for DoD use. So that's pretty exciting. And for the first time, we have this tracking of the DORA metrics with 21 commit of code and deployment to production a day at Platform One. That's pretty good for the government. It's really what enables us to move at a pace of relevance. So when you create something like Platform One in your organization, you want to make sure you're bringing options and scale, and you don't have a one-size-fits-all, but you also need to think about some of the key enterprise services that you're going to need to enable the teams to succeed. And so Repo One is the central source code repo where we put all the source code and infrastructure as code, all the container code, everything is there. Iron Bank is the container signed and assessed by the team, and so people can go and consume those containers in the Iron Bank. And then we created two main models to consume all this and instantiate it. The Polybus is a multi-tenant environment that we manage, we host at different classification levels, and development teams can just come and use it. And it's a per developer per month model where we can onboard a new team, and they don't get to pick all the tools. They just inherit that environment, and they can focus on building software. And we support 16 programming languages, 23 databases, and so on. Now, the Big Bang is a dedicated enclave, so teams that want to deploy on premise, at the edge, on jets, on bombers, or hardware embedded testing in the loop, whatever it is they have to do, they can take Big Bang and deploy it anywhere. So we have the Big Bang code on Repo One, so anyone can take Platform One and deploy a dedicated instance of Platform One on your cloud or your environment. That gives a lot of flexibility. We have a lot of companies outside of DoD starting to use Big Bang to instantiate the DevSecOps stack from scratch and contributing back code to Platform One, so we can all be stronger, faster, better together as a team. The training is foundational. So, all this technology is moving very fast, and obviously we have to learn and continuously learn. And that learning is enabled through continuous learning and learning hubs. So we have a cloud sandbox, we have unbiased content we talked about, and then we have workshops of 1 day to 3 days, all the way to the two full month minimal viable product, where we embed people of Platform One into a team and we help them move to DevSecOps. The service mesh is really what enables the traffic to flow between containers and enforcing the zero trust access. And effectively, it runs as a proxy, brings that baked-in security and visibility across containers without any code change to the container. And it brings that mutual TLS encryption. So even if teams don't even think of encryption, I don't care, because the containers will have that injected as a sidecar, and the reverse proxy is going to inject a mutual TLS tunnel across the entire stack, and bring service discovery, authentication, dynamic routing, and all the cool things of chaos engineering and observability and fault injection and layer 7 load balancing. So if you don't know what a service mesh is, check out Istio. There are others as well, but we use Istio in DoD, but there are many options. It's a game-changing concept. There's no way to build software in 2021 using microservices and having this concept of modular Lego blocks if you're now using a service mesh. Now, the big foundation of Platform One is the concept around the automation to instantiate the stack. Infrastructure as code is the concept of everything is code, no human going to production to make code change. Everything goes into a code change in Git, and then that triggers the pipeline to deploy that change. So you have no drift between environments. It's immutable, it's applicable, it's automated. It reduces attack surface by removing humans from production environments and reducing insider threats and configuration drifts. Everything effectively becomes code, which is kind of the evolution of GitOps, where everything is in Git. Git becomes the single source of truth of the entire stack, and everything is code, including your networking and configuration changes, and it creates a desired state of truth in Git, and everything becomes auditable, and you can do your compliance assessment directly in Git, and gives you this consistent deployment and rollback if you have issues, so you have no drift between environments, and you can do your change management enforcement through Git merge requests or pull requests by enforcing how many set of eyes on code you have to approve that change. And that gives you that great capability for disaster recovery. All you have to back up is your databases and your Git repo, and you can reinstantiate your stack anywhere at any time with a push button deployment. We use Kubernetes to pull from Git, so it's not a CI/CD pipeline pushing into staging or pushing into production. It's a pull, so the CI/CD tools don't have access to the clusters, and there's no keys to access the clusters. Effectively, it's the other way around. It's a pull, and so Kubernetes will check every minute to see if there is a code change and apply it in staging and production. To do that, we use Argo CD and Flux, which are also part of the CNCF. So I know that was a lot. We covered quite a few topics. There's a lot more on the website with videos of more French guys, me talking about some of what we're doing in DoD, and hopefully, that's what's exciting enough to get you to want to participate and learn more. If so, check out the website. And again, if you have any questions, you can always reach out to us at af.cso@us.af.mil. Thanks a lot.
Nicholas, that was a fabulous presentation. Fabulous. It was I really enjoyed that. It was almost quite mind blowing in terms of and that leads me on to my first question. Just the sheer scale, the vastness of new technologies you described on some of your slides there, and the massive leap forward in terms of how software is now being produced and managed. It made me think and wonder, is what kind of challenge does this present for skills? Is finding people who are familiar with these new tools, is that difficult, more difficult now, or do the tools make it easier because of the automation that, you have less of a skills requirement?
I think it's very difficult to find people that understand even most of what I even talked about today at an entry level, let alone at an expert level. Despite the fact that sometimes it's a little bit easier than what other had to learn 20 years ago, the fact is it's still pretty complex and very fast moving. I think what's interesting is, and I'm not just saying that because I created my company, I was 15 and I didn't go to college, but the fact is the self-learning ability of someone is going to be the determining factor whether or not that person is going to be able to keep up in IT. Just moving too fast now to rely on train the trainer or schools or certifications or anything like that. You look at the technology we talked about today, like Istio and service meshes. That didn't exist 3 years ago, and now it's a foundation. It's critical to the success of organizations. And so, by definition, the pace of learning is increasing and continue to increase. And so, by definition, that self-learning ability to learn on your own is going to be what's going to define the best engineers in the future.
Right. So it's much less these days about any formal qualifications, and it's about the fact that if you're not self-learning, if you're not keeping yourself up to date with these technologies by doing it and making sure you're using all these tools, you'll simply fall behind. And the scale of technologies you described there, would just be too much for people to keep up with.
Yeah, and it's also interesting because it points out that the people that are not passionate, and that did this maybe for the money or just because they like the idea of IT or that was the right thing to do because they knew there was a lot of opportunities out there. I consider myself to be someone that's passionate about IT. I started coding at 7, started very young and stuff like that. But obviously that's a passion, so I don't mind learning, right? I think it might be a little bit tougher for people that are just doing this because it's to put food on the table, right? And it's a job like any other, and they don't have that motivation to continuously reinvent yourself. There's probably no business or no job in the world that will require such drastic continuous reinventing yourself than IT in the next few years. Even other fields don't move as fast as this. So that's a little bit concerning, obviously, to a lot of people that don't like change too much.
Yeah, understood. And that leads me on nicely to my second question, which is the topic of legacy systems. So from what I understand, from what you're describing there, you're talking about, the coding of new applications, but obviously in an organization as large and historical as the US military, there must be a huge array of older systems of mainframes and so on and so forth. How are those older technologies been factored into? Oh, here's one I prepared earlier. So
well, yeah. No, I mean, I get your question, right? I saw it coming, and we're doing this with very old. And in fact, when I started, I wanted to demonstrate this could be done on very old legacy systems. The first thing we've done is we put Kubernetes on F-16 jets that are 20 plus years old. And we were able to do so without changing the hardware, and so we were able to run Python, Go, and Java on 20 years old jets. So the way we do it is using the strangler pattern and moving the legacy to DevSecOps. And I'm not going to do justice here to explain the whole process, but the key is to take bytes of the legacy and refactor while improving it. So you're not spending 3 years just refactoring. You're improving, delivering new capabilities, new improvements while refactoring. And we have a great process for that. There's a lot of great training online on the strangler pattern. That's the only way, honestly, to move any kind of brownfield / legacy existing stack or to modern DevSecOps.
And presumably that kind of ties us back to the first question, which is there'd be an opportunity to be modernizing skills as you're doing it. So those who are, skilled in the old technologies can be coming along on the journey with you as you modernize the technologies. They're learning and modernizing their skills too. Yeah,
I think the issue though is, we're doing that now, and it's a little bit crazy to ask a team that's been doing nuclear systems for many years to move to DevSecOps, and the first project they're going to learn DevSecOps with is going to be oh, by the way, we're going to move a nuclear systems to Kubernetes. That's a little bit of a big lift. If you have to start, you probably want to start with something a little bit more simple than a nuclear project moving to DevSecOps. So there is that too, right? I think we're not doing a good job at this right now. It's like, yeah, we're going to just throw it in the lion den and hope for the best. You've never done Agile. You've never done DevSecOps. You've been doing waterfall for the last 20 years, and you're going to suddenly wake up and be a Agile expert and DevSecOps guru overnight. And oh, by the way, you're going to do that with a weapon system that's 70 years old, and it's, oh, by the way, it has a nuclear nuke on top of it.
Yeah, wow. So last question then for today's session. This is such a state-of-the-art approach you've got here now, the whole system, the combination of technologies. Is this common across the whole US government? Is there opportunity for it to become a common approach across all agencies and across the whole US government as a whole?
Yeah, it's a great question. I think it's not the standard. It is becoming kind of the North Star, if you will. A lot of agencies reached out. We have about 12 agencies outside of DoD starting to use pieces of what we do, whether it's the training, the culture, some of the code, some of the containers we harden. It's happening now. You know, of course, there's maturity levels, there's different barriers. I always tell teams, though, that you know, if we can do it with nuclear systems and jets and bombers, most other agencies have a easier path to success than we do because of the complexity of the mission that we have and the impediments of real-time systems, flying jets, you know, a nuclear surety, airworthiness assessments and stuff that we have to do that, you know, someone doing some web application wouldn't worry about. So I guess the good news is if we can do it, anyone can.
Yeah, brilliant, brilliant. So on that note, we'll wrap up now. So I'd like to extend you a huge thank you for taking the time out of your very busy schedule to share that with us. As I introduced, our goal here was to share best practices from around the world of the cutting edge practices that are going on, and that was most certainly an exemplar of you know, world leading innovation that just shared so many insights and practices about what you guys are doing that others will find invaluable. So I can't thank you enough. And I wanted to give an especially big thank you to Smokey.
Indeed, he's been Baby Yoda and Smokey the Bear are foundational to our success.
Yeah. Yes, you gave us especially great quality for the presentation today. So again, thank you very much for your time. Great speaking with you, and have a great day.
Thanks for having me. Thank you.
Bye for now, Nicholas.
Bye.